Welcome back to Algebra 1 with Miss Betsy. Today we're going to be continuing our investigation of inequalities. And we're going to see what happens when we multiply or divide inequalities by a number. What we learned in our last section is that if you add or subtract a given amount to both sides of an inequality, that inequality still is true, much the same way as when you add or subtract any amount from both sides of an equation, the equation is still true. We're going to see, however, that when we multiply and divide, we've got a little bit of a twist in there that makes things different. Today I'm lecturing from pre-algebra from Algebra 1 for Christian Schools, second edition, published by Bob Jones University Press. I'm in section 5.3, which is properties of inequality, multiplication, and division. So let's go ahead and pray and see what our lame joke is, and then we'll get started. Lord, I thank you that you love us and that you created and designed us to be in relationship with you. Thank you that you are personal. Father, I ask that you would help us to be diligent in our studies and that you would give us ears to hear what you would speak to us and willing hearts to obey you. Father, I pray all of this in the name of your Son, Jesus. Amen. Okay, now in our last section, what we did was we saw that if we added or subtracted a given quantity to both sides of an equation, as we were reviewing, that of course was true, and we saw that we had the same truth of the inequality here if we added or subtracted. But what we're going to do, as I said, is we're going to multiply and divide and see if that has a differing effect on what happens with our inequality. So first, let's do multiplication, and I have 3 is less than 5. What happens if I were to multiply both sides of this inequality by a positive 5? I'm going to go ahead and use different colors here because I've learned that the different colors help me as well while I'm trying to teach and think and write and be a couple of steps ahead at the same time. 3 times 5 is 15. And 5 times 5 is 25, so far so good. If we multiply both sides of an inequality by a positive number, our inequality still works. Well, what if instead of multiplying by a positive 5, we chose to multiply both sides of this inequality by a negative number? Is this still going to work? We're going to multiply both sides of this inequality by negative 5. And we now have negative 15. Is negative 15 less than a negative 25? Well, no, that would be a fail because on our number line, obviously, there's our 0, there's our negative 15, and there's our negative 25. Negative 15 is not less than negative 25. What would we have to do to make this to be a true statement? We could change the direction of the inequality. Instead of saying less than, we would say that negative 15 is greater than a negative 25. So that works here, didn't work here. Well, let's go ahead and look over on this second section here, where we have 10 greater than 6 and 18 greater than 6, and see what happens when we divide. Let's go ahead and divide both sides of this inequality by a positive 2, and see what happens. Is 10 divided by 2 still greater than 6 divided by 2? Do we still have a true statement? Sure. We have 5 is greater than 3. So it works there. And of course you know where I'm going now. I am going to divide now by a negative 2. Let's see what happens. 18 divided by a negative 2 is a negative 9. Is a negative 9 greater than a negative 3? Is a negative 9 greater than a negative 3? Of course not. But how can we make this true? if we change the direction of this inequality symbol, then we have a true statement. Negative 9 is in fact less than a negative 3. And this is the little tweak that you're going to have when you're solving inequalities. When you multiply or divide by a positive number, your inequality stays valid. It's still a true statement. But once you multiply or divide by a negative number, it doesn't stay the same. So this gives us a rule that is very different and very essential for when you're solving inequalities. And that tells us that if you multiply or divide an inequality by a negative number, you have to change the direction of your inequality symbol. And they use some algebraic language in your text to say, well, if c is greater than 0, which means it's positive, if you say c is less than 0, means it's negative, you do this and you change the direction of the inequality. This is what it means in plain English. I want you to write this down and I want you to learn it. When you multiply or divide an inequality, not an equation, an inequality only. When you multiply or divide an inequality by a negative number, you must change the direction of that inequality symbol. Change the direction of the inequality symbol. This is not optional. If you do not change it, you will have a statement that is not true, and you won't be able to solve your inequality properly. Okay? When you multiply or divide an inequality by a negative number, change the direction of the inequality symbol. And let me just do a couple of examples here. It's very straightforward. They have 3. Let me go ahead and do 1, 2, 3 very quickly for you. We have 8 divided by a negative 2. This is example 1. 8 divided by a negative 2 is greater than a negative 7. What are we going to have to do here to isolate the variable x? It was divided by a negative 2, so we have to multiply both sides of this inequality by a negative 2. And when we do that, because we're multiplying by a negative, the direction of this inequality symbol is going to have to change. Our negative 2's cancel, and we now have x is less than 14. That's going to be the solution to this problem. There's nothing out of the ordinary that you have to learn here. Just have to remember, when you're multiplying or dividing an inequality, we have an inequality here, by a negative number, we're multiplying by a negative 2, you have to change the direction of the inequality symbol. We went from a greater than to a less than. What they mean by change the direction is put the point of that arrowhead or that fish mouth, put that point, just switch it to the opposite number. It's example number 1. Example 2 is really sort of pointless to be in here because you guys already know how to do this. 3x greater than 9. We have multiplied by a positive 3. Now we're going to divide both sides of this inequality by a positive 3. And we have x is going to be greater than 9. You notice that the direction of this inequality symbol here doesn't change. The direction of the inequality symbol only changes when you multiply or divide by a negative number. It doesn't change when you add or subtract a negative number. It doesn't change when you multiply or divide by a positive number. It only changes when you're multiplying or dividing by a negative number. So let me do this final example here. It says negative 5 is greater than or equal to 25. And you can already tell me, probably even before I get this board erased and the problem written, what the solution is going to be. We have negative 5x greater than or equal to 25. We multiplied by negative 5. We have to divide both sides of that equation by a negative 5. Because we are dividing by a negative number, you have to reverse the direction of that inequality. So instead of greater than or equal to, x has to be less than or equal to a negative 5. That's all that's involved in doing these problems. Just make sure that you don't get cranking along so fast that whenever you all of a sudden have one in here where you're multiplying or dividing by a negative number, that you forget to switch the direction of that inequality symbol. So work on these, give me a text if you have problems, otherwise I'll see you in class on Friday.